Okay, now let's move on to the next part. We want to use the KPT to describe the differences in the properties. So this one is the one that we're going into now. We talk about the difference in the properties of solid, liquid, and gas. Okay, so first one, we say that solid has fixed shape and fixed volume. So we talk about two things here, fixed shape and fixed volume. Why fixed shape? Think about it. The particles are held together by very strong forces of attraction. So they cannot move about freely. Okay, now if they cannot move about freely, okay, imagine your particles are stuck there. Can the shape of your solid change? No. That's why this one is actually the key point over here. They cannot move out freely because of the very strong force of attraction. Hence, the result of it is that they can only vibrate about their fixed position. Okay? So you can see here, because of the very strong force of attraction, they cannot move about freely, so they can only vibrate about their fixed position. Therefore, they have fixed shape. Okay? Now, how about fixed volume? Think about it closely. Okay, when you talk about fixed volume, we're actually comparing whether can the volume change? Can the volume change? Okay, when you talk about whether the volume can change or not, we're actually comparing about the compressibility. Can the particles, okay, this actually refers to can the particles be pushed closer together? Right? Can the particles be pushed closer together? Now, obviously think about it. The particles are already very close to one another. So can they be compressed anymore? No, they can't be compressed any further. Therefore, it has a fixed volume, okay, because it cannot be compressed any further. Okay, so the key thing here is that they are very close to one another already. Therefore, they cannot be compressed, and so it has a fixed volume. So you can see here, you can see the logical flow in this. Okay, now we have done with solids. We talk about why it has fixed shape and fixed volume. Now let's move on to liquids. Okay, for liquids they have fixed shape, but they do. Liquids does not have a fixed shape, but they do have a fixed volume. Okay, does not have a fixed shape, but they do have a fixed volume. Now, why no fixed shape? The key thing here is that if the particles can move, the shape can change. So if you think about, we are actually comparing about the movement. So for the force of attraction between the particles of a liquid, they are weaker, okay? Weaker than that of solid. Hence, the particles of the liquid, they are not held in fixed position. Okay, because the force of attraction is weaker, they are not held in fixed position. Therefore, if you think carefully, because of that, now how are my particles moving? They are moving freely by sliding over one another. So if the particles can move, they are not held in fixed shape due to the weaker force of attraction. That's why my liquids do not have a fixed shape. Okay, so you can see here the flow. Force of attraction weaker, now they are not held in fixed position. The particles can move, and that's why they do not have a fixed shape. How about the fixed volume? Same thing here. When we talk about fixed volume, we are talking about can the particles be pushed closer together? Can they? Think about it. Although the particles of the liquid, okay, yes, they are further than compared to solid, but they are still packed quite closely together. If they are still very close together, do you think you can compress them? The spacing between them is already close, so you can't really push them any much further. So therefore, because they are still packed quite close together, therefore they cannot be compressed, and hence they have a fixed volume. So you can see the logic here again. The particles, if they can be pushed closer, you talk about compressing them. Okay, then yes, the volume can change. But in this case, for liquid, the particles are already close together. You can't change the volume of the liquid. Now let's move on to the last one. We talk about gas. Gas do not have fixed shape. Also does not have Okay, obviously English or error there. Okay, let me correct my English. Okay, because we took gases here, so it should be do not, do not. Do not, do not. Now. So, gases do not have fixed shape, do not have fixed volume. So why does it not have fixed shape? Think about it, okay? Your particles have a lot of kinetic energy. They are definitely not held in fixed position. They are moving rapidly in all or any direction. So if your particles can move, okay, they do not have fixed shape. So not held in fixed position, can move rapidly in a direction, therefore they do not have fixed shape. How about the next one? Fixed volume. Same thing here, okay? Same thing here. We are talking about whether the particles can they be pushed closer together. We talk about the spacing. Spacing between particles. Okay? So you can see here that particles have very weak force of attraction, therefore they are spread far apart. So if they are far apart, you can see here that there are many spacing. Okay, a lot of spacing over here. So the wide spacing allow the gas to be easily compressed. Wide spaces between particles allow the particles to be easily compressed. Okay, the spacing between the particles to be easily compressed. So therefore, when the particles can be pushed closer together, the volume of your gas will change. Therefore, it has no fixed volume. The higher the pressure, okay, the more you exert pressure, okay, on your gas, the gas will start to become smaller and smaller in volume. So this is how we use the kinetic particle theory to describe the different properties of your states. Okay, so that's the end of this part over here.